Welcome. My name is Harsh, and I'm the founder of this exciting startup whose mantra is just assemble mobile apps. Our vision is that you should be able to assemble apps like assembling the Lego pieces together to make what you want to make rather than understanding how to code them. There are tens and thousands of apps that need sign up, login, and logout functionality or integration with social networking sites like Facebook and Twitter. And there are lots of apps that need location services, in-app purchase, push notifications, and so on. Why can't there be pluggable module that contains this functionality and you just need to integrate it with your app that runs seamlessly on both iOS and Android? Appemble provides the methodology and tools to build cross-platform and native mobile apps using XML. Yes, using XML, you can code most of your application. Now let us see what are the pain points in developing an app. We are all working in a very fast-paced environment. Once we get an idea for an app, we wish that if we could develop that in a day. We want to start using it or selling it immediately to maximize the user base. However, that is not the reality. It takes time to write an app and make it work with good performance. Mobile application development demands multi-platform support, multiple screen sizes, it has frequent release cycles, and of course, all developers need very powerful debugging capabilities. Appemble strives to address the demands of mobile application development. Appemble Solution includes a methodology and tools to write cross-platform apps in XML-based markup language that is simple to learn. We follow a declarative programming style which makes the learning curve very small or very low and considerably reduces the code size. Cross-platform means that the same XML code can be used to create an app for Android and for iOS. Using source code control system, you can develop on Android and run in Xcode and vice versa. Let us say we want to build a screen that runs on Android and iOS. This screen contains a little bar on the top and a list control that contains the shopping list items. The look and feel is quite similar. On Android, you have the tab bar on the top, while on the iPhone it's at the bottom, and that's the way the applications are a little bit different on each platform. Here is the XML code for my shopping lists. This is just 12 lines of XML code. It uses simple XML tags like screen to define the screen and its attributes, and control to define the various controls on the screen. The title controls are defined in line 2 and 3, and the list control with all its children is defined beginning at line 6, along with its local data source. So what tools are needed to write an app using XML? Android applications are developed using Eclipse. It's an integrated development environment and is open source. And iOS applications are developed using Xcode. This is an integrated development environment for developing apps in iOS. The look and feel is similar to what we saw in Android earlier. The biggest advantage of using XML is that one doesn't have to spend time in learning the native APIs for Android and iOS. The learning time is drastically reduced and we can write our first screen in a matter of hours. Let us bring the focus back on declarative programming. To understand, let me explain the imperative programming first. When you're writing an app in Java or Objective-C, you need to code step by step what you want to do. A simple screen or simple action like save data to database is a multi-step process. Step 1, open the DB connection. Step 2, create the cursor. Step 3, execute the query. Step 4, close the cursor. Step 5, close the database. However, in declarative programming, you would just say, I want to save this data and let the underlying software do all the steps that are needed. Advantage of declarative programming is that you need to write significantly less code, know less about how to do, and concentrate on what to do. Let us see more examples where declarative programming can significantly cut down on the code size and debugging and testing efforts. Push notifications is a commonly used feature in apps. If you are coding a native app in Android SDK, it will take about 600 lines of code to implement this feature. On an average, it takes about a week to learn Google Cloud Messaging and then another few days to implement it in your application. You need to learn about how Google Cloud Messaging intent service works, how the receiver works to receive the push notifications. But if you use XML, then it takes about 6 lines of code to register and deregister your device with your server and Google Cloud Messaging server. Similarly, let us take another example of in-app purchasing. It is a very commonly used feature that generates revenue out of your app for all the hard work you did in creating it. To integrate this feature with Google, Apple, and Amazon, it takes about 1800 lines of code. In-app purchase is all about having following actions. Get the product info available from the marketplace, request a purchase for an item, and if the purchase is successful from the marketplace, receive an event called product purchase state change so that you can register with your own application and servers that this user has purchased this premium feature and then unlock those features. With the use of plugin, it takes only about 10 lines of code to integrate with your app. Appemble Solution create native apps. So let us talk what does native means and why develop native apps. Native apps are those that directly run on iOS or Android operating system. Apps that are written using HTML5 or JavaScript and run on browser are not native apps. Native apps provide rich user experience, give better performance, and are more secure. While building native apps, the developer uses Eclipse for Android apps and Xcode for iOS apps. The debugging is easier and faster in these integrated development environments. Now, let us see what it takes to write an app. When you get an idea of an app, the first thing is to give it a shape on a piece of paper or using a software. We can make wireframes in the old way with pencil and paper or using a drawing tool like Word or Visio or any other prototyping tool. After completing the wireframes, then you start making the technical architecture and design. Here you establish how the data access layer will be written, the design of it, the business logic layer design, and the presentation layer design. The third step is the implementation phase. Here you start to code the app in Android or iOS IDE. Let us walk through the different stages while coding the app. The first step is to create the user interface. Here you create the screens with different UI elements like text, edit, push button, etc. and give a screen its look and feel. In the second step, you populate the data like static data like label or dynamic data that could be residing on your local phone or coming from the remote server. In the third step, you would attach actions to users' gestures like tap or flick. And here, using events and actions, you can create the navigational flow. You can save the data to your local or remote servers. You can retrieve the data from remote servers and so on and so forth. And lastly, you attach the business logic. For example, you want to validate user inputs or upon a user action, you want to save the data to the remote server. Appemble provides you with the tools to write native apps that can run on both iOS and Android with the same code base. So how do we achieve this? Appemble provides a virtual machine that is written in native SDK for Android and iOS. The virtual machine interprets the compiled XML code at runtime to render the UI with native APIs. The AVM creates event listeners so that it can detect the event occurrences and call actions if there are any attached to them. Because the AVM is written in native SDK, the performance of the app is same as if you were to write the app yourself in native SDK. The only addition is reading and interpreting the XML at runtime, which is about 1/10 of a second for an average size screen. XML is an XML-based markup language using which you define your mobile app. It's quite easy to understand and human readable. Using XML, you can define the user interface, define the data sources for each screen or control, attach actions with controls or a screen to be invoked on certain events. The XML code is compiled and is stored with your app. This is pretty cool. The AVM abstracts much of the underlying SDK's functionality. So if you define a control, a text control, it is rendered as a text view in Android, and on iOS it is rendered as a UI label. So why should we be using Appemble Solution? Designers and developers can write apps faster with less code. They can share code between iOS and Android. They have native debugging tools which are quite powerful. The app development is fast because of the plugin system. A plugin can be a complex control like cover flow. A cover flow control allows you to view images with animation. Plugin needs to be integrated with your app and not coded. Plugins can provide complex functionality like push notification, in-app purchase, location services, again to be integrated and not coded from scratch. Plugins enable integration points with popular APIs like Facebook, Twitter, Salesforce, etc. Appemble can be scaled, or apps can be scaled to any screen size because you give the dimension in terms of percentage of device's physical screen size. Apps can be written by tech-savvy designer, and most of the app can be written by the designers, and product managers can work with designers to get the initial app in front of the user and get user validation early in the development phase of the app rather than having it coded completely and then going to the user interface user for validation or for their input, and that is much costly and time consuming cycle. The go-to market is cut significantly as well. And that brings a closure towards the end of our presentation here. We also did a case study of how Appemble performs when we compare it with writing an app in native SDK versus we write using AVM and XML. We saw that this particular app, MedSimple, it's a medication management application, and it was initially written in native iOS and then we rewrote in XML. We saw that we were able to achieve a code reduction of 84%. Development resources were cut down by 70%. Development skill set was also distributed between the designer and the engineering team. So our designer could develop more than 50% of the app by herself. And testing resources saw a reduction of about 50%. Feel free to contact us for any help that you may need while developing mobile apps written in XML. And thank you for listening this initial introduction, and happy mobile application development. Thank you.